The Commodore Amiga can display graphics using up to 4,096 colors. It can also do a lot less. From the launch of its very first model, the Amiga was practically defined by its graphical capabilities. The original chipset, or OCS, was capable of displaying up to 32 arbitrary colors on screen simultaneously in a multitude of resolutions. Later advanced graphics architecture, or AGA machines, bumped this limit all the way up to 256. All Amiga models could also showcase their entire 4096 color palette all at once when using a technique known as hold and modify, or HAM. This mode was most often used for displaying static images or creating art using programs such as Deluxe Paint shown here. Today, following our tradition of answering questions no one was even asking, let's take a look at another nearly forgotten graphics mode offered by the system. Here's a diagram of the Amiga's AV connector on the back, courtesy of allpinouts.org. The first couple of pins have to do with gen locking, and we looked at how that works in the fan subbing episode a while back. We also have analog RGB. This is the most desirable way to connect an Amiga to a computer monitor, as it yields the sharpest image and color reproduction possible. The system also provides composite sync, as well as separate horizontal and vertical sync signals for use with monitors having different requirements. Two things notably absent here are composite and RF output. These were most commonly used in the 80s and 90s to hook up to an existing television. For that, an external converter in the form of this Commodore 520 would have been needed. Now, I deliberately skipped over something earlier, so let's scroll back up. On pins 6 through 9, we have digital red, green, blue, and intensity, or digital RGBi. Sound familiar? That's because it's what the Commodore 128's 80 column mode uses, along with IBM's Color Graphics Adapter, or CGA. Let's take a look at how this video mode is implemented. Introduced in 1981, CGA was IBM's first foray into color graphics for their PC line and became the de facto standard until it was superseded by EGA some 3 years later. The specification defined a fixed palette of 16 colors that could be displayed simultaneously in text or low-res modes. When using high-res 320 by 200 graphics, 3 palettes of 4 fixed colors could be used, giving CGA its distinct appearance. Unlike analog RGB that can produce a virtually unlimited number of shades by varying the levels of each color signal, the digital RGBi signals used by CGA are binary. They're either on or off. With 3 bits to define the color and 1 bit to define the brightness, there are only 16 possible combinations available. Black results when all the signals are off. White when all the signals are on. For each primary color, there's a dark version when the intensity bit is off, and a light version when the intensity bit is on. Instead of dark yellow, a single shade of brown is provided. These colors are actually defined by the monitor itself, as logic must be present to interpret the digital RGB signals from the computer and display the correct color according to the standard. As far as the Amiga's implementation goes, well, I searched through hundreds of old magazines, but only found a few mentions of the format ever being used. One article acknowledges that the output exists, but goes on to say you need a qualified electrician to do the work. I also found a company named DSI that claimed to have the necessary cable, but no price was listed. The ad only appeared in 2 issues of Amiga World and 1 issue of Commodore PowerPlay between March and August of 1986, before disappearing completely. I wonder if any of these cables were ever sold or used. No matter, we can build our own. First, we'll need a schematic for our cable. On one side, a DE9 connector used by most CGA displays. On the other, a DB23 connector used by the Amiga's AV port. I've gone ahead and matched each of the pins to each of the signals we'll need to pass through. Here's the diagram with some build notes in case you want to make your own. Next, we'll need parts. The DB23 connector we need was unobtainium for a long time. I bought this kit years ago, but it's really a DB25 that's been cut in half and had 2 pins removed. More recently, interest in the Amiga connector reached a sufficient level that enthusiasts worked with a manufacturer to make brand new parts. We'll also need some D-sub female crimp terminals. I really hate these things. This tool is used to install and remove the terminals from the connector. Don't try this without one. Next is a standard DE9 connector from a box of 50 or so that I bought for another project. It uses solder terminals instead, which I like better. And finally, we'll need some wire. This is an offcut from a past project, but a $1 VGA cable from the thrift store would do fine as well. I'll start by pre-tinning the terminals. This makes the next step of soldering the wire much easier, as you don't need a third hand to do it. So why are we doing this anyway? Isn't CGA worse? In 2023, this makes no sense at all, but back in the day, maybe you already had a CGA monitor, or a Commodore 128 with a 1902. This would allow you to get your shiny new Amiga up and running right away without having to purchase a new display. Today, we're just doing this for fun and because we can. Don't need any other reason than that. Okay, the easy part is done. Now, how about those hateful crimp-on connectors? I find the easiest thing is to preload them into the tool first so they can't move around. Next, I'll insert the stripped end of the wire into the connector, making sure the insulation is properly aligned. And voila! I made it look easy, didn't I? In reality, my success rate is something like 20%? Good thing I ordered hundreds of them since they're cheap. Okay, well, they're all on there and that's what matters. For good measure, I'll tone out every wire just to make sure I've got a good connection. Now all we need to do is install each of the crimped ends into their proper place in the connector, according to the diagram. The pins lock into place, so they need a bit of force. The installation end of the tool slips over the wire and allows you to press firmly on the metal collar of the crimp, snapping it into place with a satisfying click. That's everything wired up. All that's left is to install the strain relief and plastic shells. And there we go. Now we can experience the glory of CGA on the Amiga. I can't wait. Now, why did I make this thing so short? Well, it's only an adapter, not a monitor cable like these. This way, I can use it with any existing cable or display I already have, including the Commodore 1084 that uses a DIN input. It'll also work with this Taxan or EIAJ8 connector found on the Sears Total Video system. Of course, it'll also work with any CGA monitor with a standard DE9 input, including the Commodore 1902. Okay, moment of truth. Huh, that's weird. The machine isn't booting. Even stranger, if I turn the monitor off before powering up the Amiga, huh, sweet, it works. Well, sort of. What's weird is it was booting fine right up until I turned on the camera. Because, of course it was. Anyway, we'll come back to this issue a bit later on. Let's press on and see how the digital RGB performs. First impressions? Well, the image is sharp and legible. The colors don't look right though. The disk icon should be blue, not red. Let me load up a game and see if that's any better. Yeah, the sky should be blue, not red. I think something's wrong with my wiring. After building the adapter, I verified that each connection matched what I had in the pinout diagram, so the cable should have been fine. I did a bit more digging and found a discrepancy. Notice how in the all pinouts chart, pin 7 is digital red and pin 9 is digital blue. Now, take a look at what's published on Wikipedia. Here, 7 and 9 are reversed. I think we found the source of the problem. Let's swap red and blue. To do that, we'll use the other end of the tool to disengage the tangs inside the connector. Now, I'll use a paperclip to eject the crimped end. Okay, I reversed the two wires, so now I can reinstall them in the right place this time. Yikes, that could have hurt someone. This is what I get for using a cheap tool. Fortunately, the job is just about done. And here's the Amiga workbench with the revised cable. This definitely looks better to me. Let me launch the game again so we can see what it looks like now. Oh yeah, much better. I think it's safe to say that Wikipedia had their wiring right, so I submitted an update to the All Pinouts website. While everything appears to be working correctly now, we're faced with another problem. It's pretty unlikely that any Amiga software, Monkey Island included, took the limitations of digital RGB into account in their design. So what we're seeing is the best effort attempt of the system to display the game using the 16 fixed colors that are available. This yields some unpredictable results, like the WatchGuard's dialogue appearing as black text on a black background. All things considered, the game actually looks pretty good. I bet it wouldn't be hard to come up with a patch to fix the text color in scenes that require it. Not that anyone in the past, present, or future has or will ever play it like this. The Amiga's Denise chip is able to output 4 bits for each of red, green, and blue, yielding the 4096 total colors. To generate the digital RGB signal, only the most significant bit for each color is taken, along with the least significant bit from the blue channel for intensity. This is what we're left with, a somewhat flawed mapping of 12-bit color into the 4-bit CGA color space. Notice how the Amiga uses dithering to create this color gradient? Some of the darker shades get mapped to pure black, which is likely what happened to the dialogue text in the game we just saw. I have my desktop running in 16 color mode, but the system's default palette doesn't map well to the CGA space. We could easily create a custom palette with all 16 of the possible colors though. I found that switching to an 8-color desktop yielded a more pleasing color map. Switching back to the Workbench 4-color default icons from the 16-color glow icons I had been using improves the appearance even further. Chances are, if you were using a CGA monitor with an Amiga back in the day, it would have been for productivity purposes instead of gaming. GUI-based applications such as word processors would have been 100% usable. Terminal emulators also work fine, and since Amiga Graphics only use CGA 16 colors anyway, you'd be in great shape when dialing your favorite BBS. The default palette is still a bit off here, but that's easily fixed. Just for fun, here are a few images, first in digital RGBi, then in analog RGB, using the Amiga's ham mode. All along, I've maintained that this is basically the same as CGA, but it sure looks more like EGA, right? True, there are 16 colors on the screen at the same time, but the EGA specification requires a monitor that supports both 15 and 21 kHz refresh rates for higher display resolutions. Electrically, it's different too, supplying 6 bits of color information to the monitor for a palette of 64 total colors. If anything, what the Amiga is doing here is closer to PC Junior or Tandy 1000 graphics. While the palette swapping fade effects don't translate very well, this demo actually looks pretty great in the CGA colors. Let's swing back around to the problem I had with the Amiga not booting. After scouring the internet, I was able to find at least 2 others who had experienced a similar issue, although not specific to digital RGB. Here, a user mentions that his A1200 won't boot unless he turns his monitor on after the computer. This led me to a file on Aminet with a schematic and the following written in a text document. The Amiga horizontal and vertical sync lines are used as inputs when interfacing a genlock. If these lines are loaded too much, the Amiga will think that it has a genlock connected and won't provide sync signals. By buffering these lines, you will be able to hook up any monitor without problems. So it sounds like the issue only happens with certain Amiga and monitor pairings, so your mileage may vary. This issue can be solved by adding a buffer to the sync signals, and I've included a link to the schematic in the description. Now, before we wrap up, I had a little fun with the ChatGPT AI bot since it's all the internet is talking about these days. I asked it to create a script for this YouTube video just to see what it would come up with, and it actually did a decent job with the structure of a short-form video. However, the technical details it includes are often flat out wrong. For instance, it claims here that there are 16 intensity levels per color. It goes on to conclude that the increased precision of the digital RGB with intensity allows for more accurate and vibrant colors, making it a great option for gaming and graphic design. While I don't agree with this conclusion based on our real-world testing, I do like the suggestion of using the Amiga with a Sony PVM CRT. It's been doing its homework on the retro gaming scene, apparently. I ran the same query 4 separate times and got different responses for each. Some had wildly inaccurate technical details, while others were a lot closer to reality. This one, for example, nails the signal structure of digital RGBi, but still gets the use case wrong. I also like how it suggests loading up lemmings to test with. Why didn't I, with my superior human brain, think of that? It concludes by stating that this feature may have not been widely known or used during the Amiga's heyday, but it is still a valuable feature for video production and enthusiasts today. Thanks for watching, and don't forget to subscribe to our channel for more tech-related content. I couldn't have said it better myself. The Amiga's AV connector gives us a tiny glimpse into the minds of the designers. The inclusion of genlock capability and not 1 but 2 separate RGB standards instead of composite indicates their intention of building a business and productivity system instead of a gaming machine. In the end, the Amiga succeeded in both roles, but digital RGB played little part in either. I hope you enjoyed this bit. Thank you so much for watching, and we'll see you next time on Retro Bits.